All right, let's go back to triangles. We spent a ton of time. I'm sure it's going to be a huge part of the midterm proving triangles congruent this year. All right, when two triangles are congruent. And today, how do I know when two triangles are similar? First, the sign for similar. Everyone remembers our congruent sign, right? That was our congruent sign. All right, similar sign, take away the equals. There you go. You got your sign for similar. All right, it's called the tilde, if anybody knows that. All right, that's the sign for similar. It's the tilde. Take away the equals. And that's exactly what I'm going to tell you about these two triangles up here. They're going to be similar. Now I want to talk about what the heck happens then. If I know two triangles are similar, what do I know about them? Can you label the first triangle ABC for me? And the second triangle DEF? All right, here's what happens when two triangles are similar. Angles that match up, we call them corresponding. Corresponding angles are congruent. So angle A will be congruent to angle D if those triangles are similar. Angle B will be congruent to angle E if those triangles are similar. And then I'm sure you can guess angle C will be congruent to angle F if the triangles are similar. And also if they're congruent too, but here's where things change. Let's start talking about the sides now. The sides will not be equal. They will not be equal. Here you go, ready? Let's put a 5 on AB and let's put a 15 on DE so I could show you what happens. The sides will not be equal. And can you do me a favor? Put AC as 10 and DF as 30. The sides that match up are not equal. They are not equal, but they are in the same ratio. What did 5 match up with in the other triangle? 15. So watch. 5 over 15 will be in the same ratio as, what did the 10 match up with? 30. Grab your calculator right now. How do I know that those two are the same ratios? Go ahead. 5 over 15 right now in your calculator. 5 over 15. That comes out to be 1/3, all right? Now do 10 over 30, the other ratio we created. 10 over 30. Everyone see they're in the same ratio, okay? So the sides will not be equal if the triangles are similar. The sides will be in the same ratio. So let's see if you can figure this out then. Put 8 on BC. It's got to be in the same ratio as the other two sides. So what do you think EF's going to be then? 24. Only way I'm going to get 1 over 3. All right. So the sides will not be congruent. They'll be in the same ratio if they're similar. Just like congruent, I want a statement that says they're similar. Name the first triangle any way you want. That's what we always did, right? So let's name it triangle ABC. This will get frustrating for you because you're always in the mindset of putting the congruent symbol. That's what you're brainwashed right now to do. So make sure we put the similar sign. All right, it'll take some time to break that habit. Now, just like congruent triangles, you cannot name that second one any way you want. You have to still match up the angles and sides. All right, that will not change. You still have to match up the angles and sides, and this one's easy. DEF, DEF. Okay, so watch out. Don't put the congruent sign in there. Put the similar, and we still match up the sides and angles. And then the final thing, these two new vocabulary words, they may ask you to find the scale factor or find the similarity ratio. All that is, what ratio the sides are in. That's all I want to know. What ratio the sides are in. And we could do a bunch of things here. We could say, oh, it's 5 to 15. Or we could say it's 10 to 30. Or your calculator just said it was 1/3, 1 to 3. That's what it's asking for. If you're asked for the scale factor or the similarity ratio between two triangles, just tell me the ratio of two sides. All right, anything up there? What happens when two triangles are similar? We spent months on this. How many ways, anybody remember, how many ways were there to prove triangles congruent? Prove triangles congruent. How many ways did I give you? 5, right? 5 ways. Well, to prove triangles similar, 3.5. And yeah, I didn't stutter. I said a half. All right, I'll show you what I mean at the end. But 3.5 ways to prove triangles similar. Here's the first way. Let me welcome you to the first way. Angle, angle will prove triangles similar. That is awesome news for many of you, because all I need is 2 pairs of angles and I am finished. 2 pairs of angles, that's all I need. I don't need to know anything about the sides. If you show me 2 pairs of angles are congruent, we can stop. The triangles are similar. So look at my 2 triangles I have here. We're going to show why they're similar, doing a quick 2-column proof, just to get you guys in the mode for tomorrow. Because tomorrow we'll start all the actual statements, reasons, proofs with similar triangles. So the first method of proving triangles similar, angle, angle. And I did give you something up here, even though it's not written out. I gave you angle H and S were both 45, so they're congruent. So statement 1, H congruent to S, because it's given. I don't want you to overthink this. I want to show you how easy this is. So there's 1 pair of angles, and oh boy, help me if we can't find the other pair right now, with 2 weeks to go before a midterm. Where's the other pair of congruent angles in this diagram? Oh boy. Will he stay calm, or is he just going to explode here? Let's find out, kids. Where's my other pair of congruent angles for angle, angle up here? I already have 1 pair. Where's the other pair located? Here we go, Zoli.
Angle HOU and SOE.
Thank you very much. Thanks for naming it with 3 letters. Please don't O congruent to O. Come on. That's garbage. All right, hot garbage. Yes, angle UOH congruent to angle SOE. Oh boy. Why did Zoli say those 2 are equal? Because they Zoli, go ahead. Your reason now.
Because they are because the O is the midpoint.
Oh my God. Somebody help me. Where does it say midpoint? What type of angles did you just give me? Come on. Don't do this to me.
Are they?
You gave them to me for a reason. There's no midpoint word up there. Opposite each other, formed by 2 intersecting lines. I'll spot you the V.
Vertical.
Okay, here we go. Come on now, right? Vertical? Yes? No? Vertical? Have I showed you that term this year? Have you heard that term? Maybe not. Just asking. Have we heard that term?
Vertical angles, yeah.
Okay. I'm just making sure, because I'm sure that's going to be a big part of that midterm coming up in a couple weeks. Vertical angles are congruent. Everyone else all right? We good? And do I have angle now? That's it. I know you guys want to keep moving on because you think you should have this 8-9 step proof. That's it. We're done. Triangle UOH. And again, break your habit. Break it. I know it's tough. Break it. It's not congruent. Similar. And then make sure you match up the sides or angles in the next one. If I go UOH, I got to go what? EOS? Angle. Questions? Reason 1, angle. Also, I should mention, I don't care if you have the tilde or not. That's not going to bother me. It will in the next couple, but it's not going to bother me if you put the tilde or not. Angle. Everyone ready for way number 2? All right, take a look at reason number 2. It should look pretty familiar, huh? Side angle side. Side angle side. Now that is different from the side angle side you already know. Here's how why. Yes, the angles in between still need to be congruent. Yes, the angles in between still need to be congruent. But the sides aren't congruent. The sides are in the same ratio. How can you know if they're in the same ratio? Ready? I'll do it with you here. Everyone see 10. 10 over the side it matches up with in the other triangle. Smallest the smallest, biggest the biggest. So 10 matches up with 15. Is that in the same ratio as the other two that are given to me that match up? 12 over 18. Are those in the same ratio? And how do we check? We go to the calculator again. 10 over 15, 12 over 18. Look at those fractions for me. And what do we notice? They're in the same ratio. Also, I'll show you this because I know a lot of you could probably handle this. The other way of showing it's in the same ratio, cross multiply. See if the numbers come out to be the same. So does 15 times 12 equal 10 times 18? If it is, it's in the same ratio. All right, so that's side, angle, side. Angles are congruent, but the sides are in. Take a look. Sides are in the same ratio. All right, look at these two now. Try to explain to me why they're similar. First, is this angle at all? Angle? I have the right angles, and that's it. Don't try to make stuff up. I have the right angles, A and D, and that's it. So it's not angle, but it could be side, angle, side. I don't know. You have to test the sides. Hey, everyone. You can't just look at this and say side, angle, side, because that's what you have. You need to test if those darn sides are in the same ratio or not. How do you test? Take a side, 8, match it up with the side it corresponds with in the other triangle. 8 corresponds with... Vinny, what's 8 correspond with? 6. So is 8 over 6 the same ratio as 4 over 3? You need to test that. You can't just look at it and go, oh, that's side, angle, side. Well, it might be, might not be. And what are you finding out? Are those the same ratios? Yes, they are. So that's a good one. So triangle, here we go. Triangle BAC. Similar, get that congruent thing out of there, to triangle EDF by, now here's where I'm going to be picky. I'm not picky with angle, but I am picky here. Side, angle, side, and I do need the tilde with it. Anybody want to take a wild guess why I need it? You just leave it like that. We're proving triangles congruent with that method. All right, we're proving them similar. So that's why I need it. Good, everyone, good. So I got angle. I got side, angle, side. We're all good for method 3 coming up. Method 3 also looks pretty familiar, doesn't it? Side, side, side. Again, though, I don't need the sides congruent. I need them in the same ratio. All right, I need them in the same ratio. So please take a look at the 2 triangles I've given you up here. You need to show the corresponding sides are in the same ratio. And it's, hey, I get it. I would ask the question right away. How do you know what sides are going to match up? Small is the smallest, big is the biggest always. All right, that's what I always go by. The smallest side always matches up with the smallest side in the other triangle, biggest to biggest. So if I'm testing, I'm not assuming it's side, angle, side. I got to see if it is, or side, side, side. I start with one side of a triangle, so I'll start with 5. What does 5 match up with in the other triangle then? Whew, here we go. Lily, 10. So does 5 over 10. Keep going. Let me go 8. What's 8 match up with in the other triangle? Alyssa?
8 over 16.
8 over 16. It's side, side, side. You have to test all 3. All 3 have to come out to be the same. 13 over 26. If you want to use side, 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 it's got to be all 3, not 2 out of 3. That doesn't make you a winner. And what do you notice? They all come out to be 1/2, right? So that's why these 2 triangles are similar by side, side, side. It's not always given, though. You have to test the ratios. And then I said a half method, right? 3 1/2. All right, here's your half method. Very rarely used, but if you see it, you can use it. If you can prove the triangle's congruent by one of those 5 methods earlier on in the year, if for whatever reason you see it and you're like, oh, wait a second, I can prove these congruent, then you can also say they're similar. If 2 triangles are congruent, they're also similar. All right, now it may get used, you may see it, go for it then if you see it. All right, but that's why I call it a half method. All right, it doesn't deserve a full number. All right, let's play a little game here. Are these triangles similar or not? You could have a no here. You could have a no. So look at the first pair I've given you. Everyone sees first I've given you angle A congruent to angle R. Remember, you have three methods, because I don't think that half method's going to be used here. Sorry. I could use angle, angle. I could use side, angle, side similarity, or I could use side, side, side. Are these two triangles similar? And if they are, I need a reason. I've already given you A congruent to R. You can certainly do whatever else you need to that diagram that you think is true. All right, what do we think? Number one, are those two triangles similar or not? Here we go, Drew.
Yes.
Yeah, I like that. Yeah. What method?
Angle.
Because you also have vertical angles right there. Everyone see the angle. All right, so triangle AXB. Similar. Oh, how many people put the congruent sign? Have some self-respect. Triangle AXB similar to RXQ by angle. And again, you want to put the tilde there, go ahead. It's not required. We're good. All right, what about the triangles in number two? Are they similar? Ooh. All right, well, it's definitely not angle if they are. I only have the right angles. It could be side angle side or side side side, but that's up to you guys. You got to test the side ratios, right? Let's go. Test them out. Match up two sides, see if it's in a ratio of another two, see if it's in a ratio of the final two. Pick a side, put it over one that corresponds to it, and then pick a new side and put it over another one that corresponds to it. Are they in the same ratio? What are we looking at here? What do you think? Similar or not? Similar or not here? Shoom. Alexi. Yes, they are similar. All right, all the sides are in the same ratio. All right, all of them here. All right. Hey, real quick here. Look, this is how you, again, 9 matches up with the smallest side in the other triangle, which is 12. Is that in the same ratio as 12 to 16, 15 to 20? And this is how we match them up. And he's right. Triangle. Name the first one any way you want. I'll go MPX. Similar to, if I go MPX, I got to go what? LWA. And again, depending on how you did it, I would accept side angle side, or I would accept side side side. Either way. All right, what about 3? Go ahead. Well, it looks like this method. I don't care if it looks like. You have to test the sides. Have to test the sides. Are they similar or not? It could only be one method, right? Could only be, but only if the sides are in the same ratio. So come up with the 2 ratios that match up the sides and see if they're the same. All right, what do we think for this one? Dylan?
They're not similar.
They are not similar, correct. Again, if anybody, hey, it could be side angle side, sure, because you had the vertical angles, but watch. That side of 3 corresponds with 4 in the other one, and that 4 in the small one corresponds with 8, and these are not the same ratio. Okay? Just because it looks like it doesn't mean it's automatic. You got to test the sides. All right, any issues seeing if they are or not? All right, the biggest problem students have is coming up in this unit, and that is making your own proportion. All right, making your own proportion now, and you guys matching up the sides. That's the biggest hurdle we need to get over. How do I know these triangles are similar already? Look at what's given. Give me the method. How do I know these triangles are similar already? By what method? We'll get there, Stephanie. Angle, right? Two pairs of angles. So that means the sides are in the same ratio. One out of these four are set up correctly. One out of the four are set up correctly. I just don't want to pick the right one and move on. I want to go over why the wrong ones are wrong. So look at number one. X over 24. They picked two sides from the same triangle. Everybody good with the start? X over 24. Now they're saying, though, look where they put X across from. 9. Does X match up with 9? No, it matches up with what? What does X match up with in the small triangle? 15. There should be a 15 there, not a 9. So that's why this number 1 is incorrect, because they're saying X corresponds with 9, but as we can see, it corresponds with 15. So that one's incorrect. Let's go to 2. 24 and 9. Okay. Instead, now they're going to match up the sides right away. So does 24 and 9 match up? Yeah. Does 15 and X match up? 15 and X? Yeah, but this is not a right proportion. It's not correct. Anybody see why? It's not correct. I know the sides match up, but there is still a problem. See how they started with 24? What's across from it? 15. That side doesn't belong to that triangle, right? If they go 24 over 9, they should have started this one right here with a side from the same triangle as 24, and they did not. So the X and the 15 should be flipped there. So that one's incorrect. All right, here we go. We'll get there sooner or later. 32 and X. All right, they started the proportion out. Two sides from the same triangle. So let's match. Did they match them up correctly? 32 and 12 match up. Okay. X and 15 match up. Okay. I think we got our winner. But let's also go over why 4 is wrong. What did they do wrong with 4? Anybody see the mistake with 4? They started by matching up the sides, but there's a problem. They did 32 over 12, which I think they correspond. They match up. But what should they have started this with? A side, any side from the triangle that was with 32. Okay, so that's incorrect. So the only one there is 3. All right, real test now. Can you do it by yourself? Can you match up these sides by yourself? All right, two triangles are similar. What's the length of ML? If triangles are similar, sides are in the same ratio. So you're going to help me build a proportion right now to solve for X. Okay, if the triangles are similar, which they are. So you can start your proportion any way you want. All right, this is how I roll. I always take a side from one triangle and match it up with the side from another triangle. Some of you may want to take tailless. Some of you may want to just take two sides from one triangle and then match them up. I'm a match-up guy right away. That's how I roll. All right, that's how I roll. So I need your help. What does X, ML, side ML match up with in the other triangle over here? All right, because I'm going to put that right underneath. What does ML, X match up with? And if you can't see it, fine. Use the statement. ML is in that 2 spots for a reason, because it matches up with the other 2 letters in the same spot over there. All right, it's written in that order. Okay, so what's ML match up with in the other triangle? ML and here we go. Stellan? RQ. RQ. I look at RQ. It's got a length of 30, so I know X and 30 match up. Now look, hey, some of you may do this instead. X matches up with 30. Fine. You want to do it that way. Fine. There's multiple ways to write this proportion. All right, so everyone see how I started with side X? Now I got to start with another side from the same triangle, which is the only one I know is 7. And what's 7 match up with in the other triangle? LN 7 matches up with What do you got in the other triangle? Cormac? 21. QS. I don't care if you're trying. Hey, I don't care if your proportion looks like mine. I don't care as long as we're cross multiplying the same thing all the time. All right, now this goes back to Friday's lesson. Solve it by cross multiplying. Lucky for you guys, there's no factoring or quadratic formula here. Right, so now you have to build your own and solve it. So I match up the sides right away. You may choose to take two sides from one triangle right away. So hopefully X is 10 for you guys. All right, last one. Looks like we got two triangles here. Two similar triangles, right? Two similar triangles. Got to know they're similar. The sides measure 7, 4, and 9. All right, I don't care where they go. 7, 4, and 9. Longest side over here is 36, so that should match up with the 9, right? Longest side under here is 36. It should match up with the 9. And we're looking for the shortest side of this triangle, which should match up with 4. All right, here we go. Let's pick, you guys are going to build this together. Pick any, I shouldn't say pick any side. There is one side that does not belong in this proportion, which doesn't have a corresponding side. So hopefully you don't use that number. But all right, you can start this proportion any way you want. Give me a side length to start off with. Give me a side length. Here we go. Brendan, give me a side length.
36.
36, good with me. 36. I start with 36. With me, I always put what matches up with it right away underneath it. If you want to put an X with it, fine. All right, I always match them up right away. So what's 36 match up with in the smaller triangle? 36 and Cormac? 9. So 36 over 9. If I start with 36, I got to start now the next ratio with a side from the same triangle. X. And what's the X match up with in the smaller triangle now? 18. Lily? 4. There you go. 7 shouldn't appear there anymore. I don't want you to go on to the assignment yet, please. I don't want, because there's one last thing I have not talked about that's going to come up pretty quick in your assignment. Any issues matching up the sides here? All right. The last thing you're going to start seeing here, which is on the assignment tonight, is you are going to see a triangle within another one that are similar to each other. They're not going to be separated. It's going to be a triangle within a triangle, and they will both be similar. So A, B, C, D, E. Let me throw some lengths on here. 4, 8, X, 2. All right, so that triangle ABC is similar to the big one, ADE. When you write your proportion to solve for the missing side, full sides only. Full sides of each triangle only, meaning 2 and 8 will never appear. They are not full sides in either of the two similar triangles. I need full sides only. So when you write 4 down, what would 4 match up with on my triangle? Not 8. It needs to match up with a full side of the big triangle. So what would I write under 4? Because it's not going to be 8. That's not a full side. How long is the side it matches up with? 12. Everyone see that? 4 plus 8. So I'm not putting 8 there. All right. So now I put X. Now watch your mouth here. Watch your mouth. I'm not putting a 2 here. All right. That's not a full side of the big one or the small one. Doesn't X match up with that side? All right. How do you write how big that side is? Be careful. How'd you get 12? How'd you get 12? You did 4 plus 8, right? So do the same thing over here. How long is that side? No, not 2x. How'd you get 4 and 8? You added. So add these two, you get x plus 2. All right, 2x is multiplying. Full sides only in your proportion. Go ahead, start the assignment.